So thank you everyone for having us here. This talk is going to focus on measurement and benchmarking of LLMs, specifically for CTI. So, excuse my voice. So basically, the idea, like maybe to drive this home, if you're busy and you need to work in emails, whatever, this is the message that you need to take home. You need to measure these things. Otherwise, it's like asking an oracle. So briefly to introduce ourselves and the whole topic and how this came to be, there is an AI SIG at first, which Patrick, me, and Jeffrey lead. It's open to the audience. If you want to join, at the end you'll have a link. And in there we made a subgroup of people who are interested in this benchmarking and measurement topic. The speakers here on the stage are Syra, Paolo, and me, but it's also a wider team with Ben, a colleague of yours, Syra, and David Bianco, whom you might know, Pyramid of Pain, Jay Jacobs in the US, Marco Casali, Patrick, thank you, and Shin, and a couple of others. And Jürgen, I forgot Jürgen actually, Jürgen Brandl. Okay. So, short disclaimer, I speak only as myself here, and you run your own companies, started companies, so you do speak for your companies also, that's great. All of this is still very much work in progress. So we decided to still submit that talk and use that opportunity to actually push ourselves to get something out there. But it is still work in progress, and I think it is work in progress for most people, to be honest, because getting a good CTI benchmark data set is hard. So we will talk about 5 use cases. We split the problem of CTI and AI, or CTI and LLM, or CTI and natural language processing, NLP, into 5 arbitrary use cases that we are interested in. I'm not saying this is the only way to do it, but that's what interested us. So first is, you know the threat landscape reports. It would be great to have automatic summaries. Like, yeah, that's a chore for most of us. So yeah, summarization is really cool. Another is question answering, or also called retrieval augmented generation, where you can basically chat with your documents and ask questions like, did APT 41 do this and that, according to the documents? Another one would be information extraction, often called named entity recognition, where you basically like want to have certain parts of the text tagged, like here, that is a TTP, or that is a threat actor name, right? A special version of that is mapping of TTPs to MITRE-T codes. It's a classification problem. And then you're going to talk at the end also about extracting relationships, and that's our dream that we have, right? To have the free-form CTI report, the news report, the bleeping computer blog report, whatever, and have a STIX graph out of it and ingest it automatically. That would be cool. And I think we're on the way to doing that, but yeah, what you can't measure, you don't control. So, for all of these use cases, basically you can always apply the same questions. You can say, can we actually do it with AI, with NLP? Can we do it as good or maybe even better as humans? And that introduces automatically the question of scoring, of metrics, right? You need to measure the true positive rate, the false positive rate, the different scores, F1, etc. Paul is going to talk about that. Another interesting question in our field especially is if there's a true positive, a false positive or a false negative, can we actually spot it? Or if we automate it, would it pass through and it would be like a seemingly realistic hallucination, but actually is not true? So that's quite relevant. So where do you put the human in the workflow, right? The human needs to check still. So yeah. Another constraint that you have in using NLP for CTI purposes is very often we're in a constrained environment where maybe you cannot ask OpenAI.com for everything unless it's a public report. So you might have like internal feeds or feeds from feed providers which you are not allowed to share by contract or something. So you automatically end up at the point where you need a local model. So local models are notoriously not quite as good as the top-notch performers like GPT-4, etc., or Claude. So again, you need to measure. So all of that brings us to this insight. We need a benchmark data set for CTI. And we asked around in the AI SIG, and maybe we were not enough. Maybe we didn't know everything, but we didn't find much. So we took a look at the existing data sets, which could lend themselves to being incorporated into a benchmark data set. And that's where I'll hand over to Paolo.
Thank you, Aaron. So as I mentioned, it wasn't very easy to find this kind of material for training LLMs. We wanted to find something that was reliable, that had enough quality in terms of annotations, that would provide us with a ground truth, right? I found these 5 data sets. If you know any other ones, please let me know. The MITRE one, I was kind of involved working on that one. It's mostly a classification task to identify which TTP code is linked to a specific sentence. It's not all the techniques, so they took the 50 most popular TTPs, techniques and sub-techniques. And there was a team at MITRE that was paid, I can't remember how much money, but very reliable people, I would say, that essentially tagged those sentences. They also provide like a pre-trained GPT-2, I think it was, model for that data set, in addition to some logistic regression. There's more in the appendix once you download these slides. The second one, back when I was working for Fortinet, Palo Alto was one of our competitors, in terms of threat intelligence. But I have to admit they have a very nice team for threat intelligence. If anybody from Palo Alto, let me know. So they published a number of playbooks in STIX 2.1 format with MITRE object as well. They have a specific format within the STIX bundle, but they're pretty good. I think there are 83 playbooks. The only problem there is I had to find out the equivalent textual reports so that to match the actual STIX format. I used a little bit of LLM search to match possible candidates, but yeah, it's a good data set. KISS advisories, or CISA advisories, are also quite good. They are published reports. They offer a STIX format, 2.1, but also 1.0, and it's a very nice text report with IOCs. Okay, so I mentioned that one already, and then the Anno CTR, Patrick is here from Bosch. It was just released recently, so there is a paper as well, and it's essentially a data set with annotations. So let's see, go next one. The link is on the bottom, and he also referenced previous data sets, so you can kind of have an idea of what's in there. And it's basically a collection from multiple reports and also annotated by humans. So yeah, it's a good starting point, right? Okay, is it going to next? Is it moving? I don't see the slides moving anymore. Okay. So what kind of challenges do we have in LLMs and AI in general? On the left, when you're building your pre-trained models, it's all about compute and GPU farms that are wasting a lot of CO2 nowadays, unfortunately. By the size of Argentina, I think that was an old statistic, even more now, unfortunately. So I hope we'll fix this problem in the future. But it's mostly unsupervised, so you ingest all these documents from the internet, which now, OpenAI has been sort of legally challenged if they can use it or not. But anyway, so you ingest all these public source of information. You build these GPT models, which is unsupervised, so it requires a lot of documents in the trillions. And you can build all these kind of large language models. By the way, fun fact, we are at the point where the size of the actual models have overcome the content available on the internet. So now we are running out of data. So like, I don't know where we're going to get more human data, right? And GPTs are creating synthetic data, which is relearning from itself. So Yeah, that won't go well. Of course, yeah, sure. You can imagine, but let's forget that problem. And then you have to do like, you have to provide human feedback, which is the most expensive part. So you have to have annotators, right? So there are two techniques. I don't have time to go into details: fine-tuning and reinforcement learning human feedback, which basically boosts the actual, what is called the alignment measures. So like to have something that is useful for a human in terms of quality. And those are required not so much prompts, 10,000, 100,000 prompts. And that's where we basically need some help, right? So Aaron is going to show something now. If you switch the...
No, not yet.
No, is it? Next, okay.
Okay. So unfortunately, we have really like lots of material, and we cut out like 50% of the slides. So if you're interested, like really come to us afterwards and talk. And there's so much cool things, like just mentioned like the energy consumption. There's another PCI Express card which is more efficient. Anyway, there's so much, but we'll just go through that quickly now. So summarization, the use case, basically creating a summarization benchmark is, well, I didn't find really much, especially not for CTI. So the first naive approach that I use at work is let humans compare, right? So we had like 50 CTI reports summarized by an AI and summarized by a human. And we made a column in Excel, let the human rate which one is better. -10 was the AI was really bad, +10 was the AI was much better, and 0 means they're equally good or bad. And the interesting thing is the average score was 4.7. So this is like 150% of the human. Just let that sink in. That's what humans rated, the two summaries, right? And then we did another test, like another human confirmed that rating was correct. And they also had to write a reasoning why it was such. And also very interesting, the standard deviation was quite high. That means if the AI summary was wrong, it was totally off. It was a -10 very often. So in other words, it's not perfect, but it's pretty good. And if it's not good, we probably can detect it. And that leads to the question, like, how do we scale that up? Like with 50 reports, we can still do it, but with 5,000, people will get bored, right? So 50,000 reports. So I looked at automatic evaluations. There are classical metrics like Rouge, BERT score, BART score, COMET, machine translation, benchmark, etc. But still, the gold standard is the human evaluator. And then from our group, Jay came up with, I think Jay came up, or did you come up? I don't know. Anyway, someone came up with a human-like summarization evaluation with ChatGPT paper. And that's pretty cool because it's like Inception. It's like the movie where you have the story in the story. So you have the LLM simulating the human evaluator. And you would think like, well, that probably can't work, but actually it works. So there's a thing that human evaluators for summaries usually use. It's called the Likert scale score. And you have like 3 dimensions, for example: factual consistency, informativeness, fluency. But you can apply other dimensions there as well. And let the LLM answer these questions, right? And score it. And here's the prompt at the bottom. Here, oops, no, sorry. Here. If you use a LangChain, you can just pull in that prompt and use it. So some numbers compared to other metrics, it was significantly better. Yeah, and it's the paper basically. The paper is linked again here. The paper evaluates that against news reports. Our CTI reports are still in the pipeline. The machine is still crunching through the numbers. Sorry about that, but it'll be on the GitHub repo. Rag, there you go. 2 of you.
Okay. I don't know many people have heard of this keyword. It's kind of a hot trend, I believe, in LLMs now. I'll maybe describe and you can add something into that.
Yeah, sure.
Yeah, okay. So essentially, what's the problem? So fine-tuning is an expensive process. Like you need a lot of GPUs. If you use GPT-4, you know that there is a cutoff in the training date. So like any facts after that won't be in that knowledge base. So to achieve that, what you can do, essentially, you take your text corpus, like news, in our case, threat reports, You chunk it, you embed it into a vector space, which is your vector database. Then the user asks a question, which is a prompt. You will find the most similar sentences or blocks of text that match your question. And then the LLM will basically combine the retrieved context with your query to give you an answer, okay?
Just to clarify, that's one way of doing retrieval augmented generation. Vector database is a lot quicker and easier. Paolo literally knocked it out in an evening with some example. I was like, woke up the next morning, we're like, how did you do that fast? We're going to talk later, hoping we've got time, about knowledge graph retrieval, where you can actually, it can explain itself a lot more. We're going to talk about guardrails on LLMs in a moment, and for me, guardrails is how you get an LLM to do the thing right. So everyone was talking a moment ago about how you've got that massive standard deviation. It's either really good or it's absolute junk. But if you combine it with another LLM or you combine it with classical, like a few years ago, natural language processing techniques, you can sort of be doing that verification and then you can do it at scale.
Yes. And then same problem, like how do you actually know it's working, right? So you have the same problem as before, so you can either evaluate components one by one, so you can basically measure some quality score for each of these components, which actually have a lot of influence on the actual results. Like you might change one component, like the results are very different. Or you can do an end-to-end Q&A experiment, like before with the Inception, where you can say, hey, let's generate a lot of questions and let's match to what was supposed to answer.
And of course the answer is do both.
Yes.
Same as with writing unit tests, you also want to write functional verification tests because you want to know which component is messing it up. Right. So you very much need to do both.
Yeah. So it is possible to automate it to some extent, but you still need some supervision, somebody like, hopefully from the community that can basically label what, if it was good enough. There are so many metrics, I'm from machine learning.
Right now,
so you can go like precision recall, a combination of more fancy ones, so I won't go into details. And guardrails, this is kind of important. Maybe you can.
Yeah, so I've already mentioned the word once. I'm not sure whether it seems to be becoming moderately standardly used, but I found this photo is how I like to visualize it with. You've got your LLM. When it's very good, it's very, very good. But when it is bad, it is very, very bad. Or to quote the parable, when it's bad, it's wicked. But yes, so you want to put guardrails on it. Get it to check itself. Use other tools to validate that. Again, going back to more classical natural language processing techniques, and we use this at ELEMENDAR, which I'm CTO at, and we do a bunch of this stuff, but it's sadly not open source, and we're small enough that I can't make it open source. Capitalism. But the key thing that we've actually found really useful is if you have specialist models, and then they all do things, you combine it with algorithmic methods, whether it be regular expressions or whatnot, and then you get everything to validate each of its own working, and you end up with a voting mechanic, and then you actually get significantly more accurate results. And we'll come onto this more in knowledge graphs, but then when you start doing that at scale, that's when you can actually start increasing your confidence, because we've found at ELEMENDAR that you do it at a single document level. If you want that to be perfect, you will almost always need a human to come in and fix things, particularly relationships. But when you start doing that at scale, and you're doing it at many reports, this is where actually that confidence comes in on how certain you are on relationships, and you end up with more and more accurate results because you're like, well, our models, we're pretty confident they got this relationship from like 20 different reports. Oh, sorry. From like 20 different reports, therefore we can be pretty sure actually this is a solid relationship. Yeah.
Where's the radio? Okay. Now, anybody knows NER probably. There's no free lunch, as you can imagine, right? Everything is tough. So I'm sure you're familiar with this concept, so this semi-supervised loop. And the idea is, yes, you can have a base model, so you can have anything, like in the previous talk, you have Spacey and Flare to extract entities. The classical ways, you can regular expressions, which are very good, to detect IP addresses, for instance. But then you also want to have an LLM to extract like identities, company names, threat actors, and other software names, etc. So you will always start with some sort of baseline performance, like let's say 70% which I can show later. And then you extract these entities, maybe in a graphical interface, and then you can basically say, hey, this was right, this was wrong. We get that feedback, and we basically fix or retrain those models, and then hopefully we achieve a higher performance if people are doing their job correctly. And the idea is to start from, let's say, 70%, which is roughly what we have now, to go to something like 85% and more. Okay. Do you want to switch to the next one?
Yes, perfect.
Okay.
Thank you. If possible, can I have like my monitor here, like my laptop? Thank you. Not really. No. Okay. Good. Does it show?
No.
No, it doesn't show. Damn. Okay.
We're attempting a live demo.
In a short time. Yes, yes, that's right. Okay, all right. So I got it. So basically, very soon, I'll really try to be fast. Very soon, we're going to release the tagging tool, I want to ask you for your help because you're CTI folks here. I'm also going to send it out to the CTI SIG. And maybe even wider first, whoever wants to participate and has we probably can all do that. Basically, the idea is that we can take text. You have like a thing with an invitation code. You would check it, and then you would get a report. Let's say here, copy and paste that. It will be pre-labeled, and then press process, right? And basically it will pre-label something. It will look like this. That an LLM will pre-label that for you and say this is a threat actor, right here, threat actor, and it will tag it already, mostly correct, like 70–80% correct. I talked with Philip Lin before. He gets 80% out of the box. We want to achieve more, but for achieving more, we need exactly what you showed, this feedback cycle. So we need your help to correct. Right? And the nice thing is this will be fast. It'll be maybe 15 or 20 minutes of your time, and then you press save or download JSON. Well, it'll be the save button, and it will be in that data set, and your benefit will be you get the fine-tuned model out of that. Yeah? So everyone who participates will get that first. And yeah, can we switch back again, please? Sorry for that.
That's a slide, yeah, so you can move.
Oh, yeah, okay, all right, thank you. Okay.
Okay.
Yes, so you can take a screenshot from here. You got the slides also, if you want. It would be really cool to get your help. It'll take you like 15–20 minutes, like just a couple of reports, and go through it, click, 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 save, yeah? That's what we need. But we need the humans for raising the quality. And as you said, it'll be a loop. So, voila.
Okay, use case. Yeah, okay. So we did some experiments as well. So I did some experiments as well with the tagging text to TTPs. You have to be really careful about how you approach this problem, because if you do it in the naive way, you obtain this F1 score, which is 29. It's not that great. It's probably definitely, I mean, I haven't used any humans in these experiments, but it's not probably as good as a human. But if you resample that, because they're very, the distribution is very uneven, you get up to 80%, right? More than 80% performance. So that's the kind of baseline we start from. But we need more. We need more variety in this data set. We need more techniques that we can essentially label so to make the LLM better. Okay, let's go to the sticks now.
That's me. And oh no, cool. Oh yeah, so actually we can just rattle through these quickly. So basically everyone knows what I would assume probably knows what a sticks bundle is. The ideal that we get from all of this is you throw in a report, you get a sticks bundle out, and then when you've got those sticks bundles, you can start putting them together into a larger knowledge graph, which then leads into being able to use retrieval augmented generation on a graph, which means it can be more explainable. Go on button, yeah, there we go. So this is just the classic NLP goals. This is stuff that we do at ELEMENDAR, and it's stuff that we're working on to produce open models for this as well. This is just a breakdown of sticks there. So basically, those individual graphs are great, but actually it's when you start putting it all together and you start being able to query across a massive graph, that's when things start getting interesting, because you end up with sort of hybrid search. You can start answering complex questions, and when you're on a graph, you can also start doing graph neural network things to potentially reveal interesting and undiscovered facts. Like it goes, oh, there's a contradiction over here, or it goes, well, this pattern looks extremely like this pattern I saw over here, and you can start doing predictive work, which gets really interesting, though is far from trivial. And I'll pass back to Aaron to take us home.
Okay, as you can see, like many folks were working on this, lots of ideas, so lots of content. Takeaways, LLMs are super interesting. They're sometimes wrong, but without benchmarks, you drive blindly, basically. It's like, yeah, you need that. Creating a good benchmark is the hard work here, so there is no free lunch. LLMs seem to be like this magical thing, but they're not, they're statistics. And it's still hard work, and the benchmark is the hard work. No specific CTI NLP benchmark existed according to our knowledge, at least. We're attempting to create one. It's still work in progress. We need your help. Please sign up, especially for the named entity recognition tagging. Yeah, the whole thing is pretty much a monster. I love that slide. Yeah, there are all kinds of different things. Like, Philip talked about it, exactly, the naming conventions, the ontologies, we're operating on text. If it's like two different things, it's like Department of Energy and Energy Department, right? Like, yeah, there's so much pre-work that goes into all of that. Yeah, all the data sources that we could use for benchmarks, they're all different. And then there was also a good important point that Patrick brought up, like just getting the vendors to release their already public reports as open source so that we can legally use it was, I think, a 3 years project for you. So that's another challenge, basically. Yeah, we have that here. You can talk with Patrick then afterwards about the details. If you're interested in this topic, please do join the AI SIG. The chairs are Patrick sitting here, me and Jeffrey. You can reach out to us. You can sign up on the first portal page. Code will be here. And please, let's get in touch. I'll leave this standing here. Here's again the code link and the AI SIG link and the QR code link for the named entity recognition. It's a super interesting topic. The group could be bigger. As you've seen, like lots of cool ideas, lots of branches, lots of time. Endless time, of course, yeah. Yeah, so thank you.